Dear colleagues, I want to present you our paper that called the method for determining the generating capacity of the waste heat recovery system of main engines. The authors are Alexander Rak, Viktor Bushev, Alexey Cherny, Yuri Kachan, and Vitaly Kuznetsov. The presenter is Vitaly Kuznetsov. Introduction. With the signing of the Kyoto Protocol in 1997, the regulation of greenhouse gas emissions, including related economic activities, became the subject of international agreements. The UN Framework Convention of Climate Change that was in Paris was a result of the efforts of the world community aimed at regulation GNG emissions and limiting global warming. For the maritime industry, all legal and technical issues are regulated by the International Maritime Organization, IMO, within the International Convention, MARPOL 7378. IMO has taken the initiative to develop a tool to protect the atmosphere from global heat gas. These requirements were included in Chapter 4 on Annex 6 to this convention and are aimed at reducing GNG emissions not only from ships but from absolutely of anthropogenic GNG emissions, including powerful diesel and diesel generator sets in land transport. In some cases, it is assessed by taking into account the installed power and energy-saving equipment without neglecting the possibilities of using innovation technology in the energy sector, including the integrated approach to determining these possibilities at the design on reconstruction stage. In the simplest case, it is assessed according to a complex indicator of the quality of the power plant based on its consumption and resource indicators. Energy Efficient Design Index of a Vehicle Power Plant. In accordance with the above Appendix 6, it is recommended to take into account GNG emissions using the energy efficiency design indexes, which characterize the energy capability of a technical facility at the lowest cost of resources for energy generation. It is assessed with taking into account the installed power and energy-saving equipment, without neglecting the possibilities of using innovation technology in the energy sector, including an integrated approach to determining these possibilities at the design of or reconstruction stage. It is a complex indicator of the quality of power plant based on its consumption and resource indicator. This indicator you can see on this slide. Capacity is gross tonnage of vehicle. Another coefficient is the specific fuel consumption and the carbon factors for the accurately and main engine fuel. Another coefficients are the number and correction factor for the availability of innovation technologies. The growing interest in lowering operation costs for all types of power autonomous vehicle and reducing GNG emissions, including measures to ensure optimal use of the fuel used for the main engine. Following the trend for increasing the overall efficiency after the first oil crisis in 1973, the efficiency of the main engines has increased, and today it is about 50%. This high value has led to low values of specific fuel consumption and accordingly to a low temperature of the exhaust gases after the turbo Hodges. Even though the energy efficiency of the fuel consumed by 50% is relatively high, the main challenge is still further to reduce operation costs and the overall fuel consumption. It can also lead to further reductions in CO emissions. Heat balance for engine without and with WHRS. The correction coefficient of sample is figure 1 on the left shows for us the heat balance for the most common type of low-speed diesel engines. The main losses are connected with the heat release of the exhaust gases, which are about half of the total waste heat. About 25% of the total fuel energy. Exhaust gas energies is the most attractive source of waste heat on a vehicle due to the intense heat flow at relatively high temperatures. One of the ways to improve efficiency is the use of waste heat recovery system. At the same time, for the main engine, in combination with waste heat recovery system, the overall efficiency increases to about 55%. The primary purpose of the waste heat recovery system is to convert exhaust gas energy into electrical energy for onboard consumers. The purpose of our research. The purpose of the work is to develop and sustain the adequacy of this simplified method for determining of the generating capacity of the heat recovery system for the main engines of sea vessels and powerful land vehicles, excuse me. Functional diagram of the steam turbine and gas turbine heat recovery system. Figure 2 shows for us the function diagram of waste heat recovery system. The principle of operation of the system is as follows. Most of the exhaust gases from the exhaust manifold go to the turbo and charger, which ensures the operation of the main engine, and the more minor part goes to the gas turbine, which drives the generator connected to it. Hot exhaust gas passes through the turbocharger and gas turbines, enters gas utilization boiler, where the amount of water from the primary engine cooling system is heated, which is used to produce the steam sending to for electricity generation, excuse me. On this slide, you can see the calculation algorithm. The slide number 9 shows for us this calculation algorithm. In slide number 9, we can see online CES engine calculation for power 58 and 100 kilowatts. The main engine characteristic you can see on this slide. The data for a powerful ship's main engine obtained in the program are presented as graphical dependencies in this figure, and data in table number 1 on next slide. This slide shows for us the table number 1 and table number 2, where we can see the initial data for the engine of type that you can see on this slide. The power generated by difference engine you can see on this slide. The result of our calculation. Figure 4 shows for us the result of calculation as the generating power by waste heat recovery system depending on the power of the main engine. This figure also compares the calculation results with the manufacturer passport data for a similar engine that you can see in previous slide in table number 2. On this slide, we can see the result of our calculation. We will also make similar calculation for a relatively low power engine for of 3,200 kilowatts with a characteristic that's shown in this figure. Result of our calculation. Based on the obtained data, the power diagrams of the steam and gas turbines were calculated that this graphic you can see on the figure number 6. We can see that the waste heat recovery system power can reach 380 kilowatts at 100% load of the main engine that is equal about 11.9%. The produced energy can be sufficient to meet all the energy needs of the train, including refrigerator, wagons and containers. However, the stable operation of the diesel engine, graphs number 1, 2, and 3 in figure that you can see in figure number 6, can be accurately approximated by straight line segments, as was done for a Powell main engine. The conclusions. The expectancy of using waste heat recovery system is shown not only for power ship power systems, tens of megawatts, but also for installations of relatively low power from 1 to 3 megawatts, in particular in long trains and diesel locomotives. In addition, it can be seen that the proposed method for calculation of the power of gas generator, gas turbine as part of waste heat recovery system does not require complex calculations and allows only 2 operating points to obtain the energy characteristic of waste heat recovery system with an error of no more than 5%. The second, a method has been proposed that makes it possible to determine the amount of generated energy by waste heat recovery system in modes different from those given in the operating instructions for any type of main engines of which it is possible to install waste heat recovery systems. The third, using the proposed method, it is possible to determine the amount of energy produced separately by each of the types of turbine generator, steam or gas. In this case, preference for one or another type of turbine generator or their combination should be given on the basis of a technical and economic analysis, taking into account both capital investments and the power of energy consumers in the vehicle and long-term prospects for saving fuel and reducing greenhouse gas emission. And the fourth, the obtained data on the energy characteristic of waste heat recovery system can also be used to confirm of compliance of the main power plant with requirements of the MAPL 7378 convention in terms of improving energy efficiency design index and reduce GNG emission at loads of 50%, 75%, and 100%. Thank you very much for your attention.